Welcome back to our second video. In this video, what we're going to look at is we're going to look at left-hand limits and right-hand limits. We're going to look at simplifying things algebraically to find the limits. This time you're going to have to pretend like your calculator does not exist. And then finally we're going to use some graphs, some pictures of graphs to find limits. So let's look at just some examples. You understand the concept of what a limit is. The first thing you always want to check for is whatever you're approaching a restriction on your particular domain. So like, can I just plug in 1 here? In this particular case, I can. This is an equation of a line. Since that's an equation of a line, it has no restrictions on its domain. Its domain is all real numbers. So I can just plug in 1. If I plug in 1 there, I get a value of 3. So what does x plus 2 approach? As x approaches 1, it approaches 3. If it's not a restriction, you just plug it in. Make sure you always check that. In this second example, as x approaches 1, I get division by 0, which is undefined. So that is a restriction on my domain. So then I need to try to simplify the expression somehow or another so I can plug in 1. In this particular case, I'm going to simplify the expression by factoring. So if I rewrite this, the limit as x approaches 1, it's going to be x plus 2 times x minus 1 over x minus 1. Cancel those out, and so now 1's no longer a restriction. I can plug it in here. When I plug it in here, I end up with 3. The factoring will get more complex. If it gets more complex, you have some trouble with that, make sure you ask me in class. On my third example, this is one involving a square root, and anytime you see square roots, you always want to think about multiplying by the conjugate over itself. In this case, if I plug in 9 here, I get 3 minus 3 on the bottom, so that's division by 0, again undefined. So what I'm going to do is I'm going to rewrite it. The limit as x approaches 9 of x minus 9 over the square root of x minus 3. Now you always want to take the conjugate of whatever is involved with the square root, or whatever's grouped with the square root. So I'm going to take the conjugate of this expression, and what the conjugate means is I'm going to change that that minus right there to a plus. So I'm going to multiply this by the square root of x plus 3 over itself, and you have to always make sure to multiply it over itself. So you're multiplying by 1. You're not changing the value of the fraction. So then if you do that, on the top, these are not conjugates, so leave those alone. So I'm going to leave it as x minus 9 times the square root of x plus 3. On the bottom, I'm going to multiply out the conjugates. When I multiply out the conjugates, you only need to multiply first times first, which will be x, and then last times last, which is minus 9. The reason why you don't have to multiply the o and the I in FOIL is because those are going to drop out because you're multiplying by a conjugate. Now, the beautiful thing here is that the x minus 9s, these will drop. The x minus 9s will drop, so there 9 is no longer a restriction, so I can take and I can plug in 9 into this expression, and I end up with 6 as my limit. In my next example, the limit as x approaches 0 of 1 over x, what ends up happening here is that if I can't plug in 0 because I get division by 0. So then if I take a look at this, if I were to take a look at the graph of this rational function, what you see is you have this vertical asymptote along the y-axis, or when x is 0. So as I approach 0 from the right-hand side, or values that are greater than 0, it goes to positive infinity. As I approach 0 from the left-hand side, or values that are less than 0, I go to negative infinity. Since these do not converge to the same value, this one goes up and this one goes down, we say this limit does not exist. That is possible. You may have limits that do not exist as you go through these problems and work these examples. In my next example, I'm going to take a look at some more factoring, a little bit more complex. Again, if you plug in 2 here, I get division by 0, so that doesn't work. So then I need to rewrite this, the limit as x approaches 2. I'm going to factor the top, which is going to be 2x and then x, and I think it's minus 2 there and minus 1 there. However you do the factoring, that's how, go down that route. If you need help with that, please ask me. I will help you. On the bottom, it's going to be 5x and then x. And then it's going to be, in this particular case, it's going to be minus 2 there, and it's going to be plus 3 there. You can use this restriction to help you. Sometimes that will be a little bit of a key for you. And then what I'm going to do is I'm going to cancel out these x minus 2's. Those drop out. Now I can plug in 2. And I'm going to end up with 3 over 13. In our next example, I'm going to take a look at a piecewise function. These piecewise functions get a little bit more complex. In graphing piecewise functions, I find that sometimes people have trouble with those. So if you have some difficulty with graphing a piecewise function, just let me know. We'll help you. My breaking point here is at 1. That's what I'm looking at. I'm looking at 1. So if I look at this at 1, that first equation, that bottom equation, or top equation, sorry, is 3 minus x. So that's just an equation of a line. So I have a point there at 3, and then I have a point right here at 1, 2, and then I have a line going to my left. This next one is just my point when the x is 1. I'm up at 4. So I'm 1 and I'm up at 4. And then this last one is a parabola when I'm at 1. And I just kind of going this way without bound to the right. So then when I look at these limits, these are sided limits. This is the limit as x approaches 1 from the left of f of x. This is what we call left-hand limit. This is a right-hand limit, the limit as x approaches 1 from the right of f of x. And then this is just the overall limit. The key with this last part is that if this limit, if the first one is the same as the second one, then that's the limit. If these two are different, then this limit does not exist. So as I do the limit as x approaches 1 from the left, I'm on this part of the graph right here. And what am I converging to? I'm converging to 2. So this limit is 2. At my right-hand limit, as I converge to 1 from the right-hand side, I'm also going down to 2. So this limit is also 2. Therefore, this limit is 2. So even though the point 1, 2 is not on the graph, that is my limit. If I were to ask you, like, what is f of 1? F of 1, the point is 4. But that is not my limit. Finally, I thought we'd look at a little bit more complex graph. This just has all kinds of breaks in it, points of discontinuity, all that stuff, and look at some sided limits and how we might format things. This first one would say, okay, well, as x approaches negative 4 from the left of f of x, what's the limit? So I'm on this part of the graph right there. I'm converging down to 0. From the right-hand side, I'm on this part of the graph right here. And where is it going to? It's going to 8. Since these are not the same, this does not exist. What is f of negative 4? It's that point right there, which is 0. In my second one, I'm over here at 2. At 2, I had this point of discontinuity. That point's down there, and I had this point of discontinuity. We're going to take a look at discontinuity in one of our future videos at the end of this unit. As x approaches 2 from the left, I'm converging to 2. As x approaches 2 from the right, I'm also converging to 2. So therefore, as x approaches 2, it's also 2. But f of 2 is negative 3. So this is completely different than this limit. These limits are like, what is it converging to? This is what is the actual point. And then the same idea with 6. As I converge to 6 from the left-hand side, I'm right there. That's at 2. If I converge to 6 from the right-hand side, I'm up here, which is up at 8. So what is the limit as x approaches 6 is does not exist. And then finally, f of 6 is this point right here, which is at 5. Okay, so it's the algebra that tends to get people in trouble in this part of the unit. And if you have questions about as you simplify things, have some questions, please ask me in class. And good luck. I'll talk to you when we get in class.